Now let's take the very first question. Here it says that the total number of ways wherein a beggar can be given at least 1 rupee from 4 25 paise coin, 3 50 paise coin and 2 1 rupee coin. So what we can do here is that let us try to figure out all possibilities irrespective whether the beggar is getting 1 rupee or not, right? So here for 25 paise we have 5 options, right? Because we have 4 25 paise, so the number of options is that we can give 0 25 paise or 1 25 paise or 2 or 3 or at max 4. So for to offer 25 paise we have 5 options. Similarly, to offer 50 paise there are 3 to 50 paise, there will be 4 options, and similarly for 1 rupee we'll have 3 options. So overall the number of options is 60. This is a case wherein a beggar may be getting a 0 rupees or may be getting all the coins, right? All the 425 coins plus 3 50 paise coins and 2 1 rupee coin. In this scenario, we have to just deduct those cases wherein he is not getting 1 rupee coin, right? Or he is getting less than 1 rupee coin. So of course, if he is getting 0 coin, that is the only way wherein we are not giving any of the coin, right? If he is getting say only 25 paise coin, that can be done only one way, that is just giving 125 paise coin. If he is getting say 50 paise coin, then there are two ways. One, we have 25 paise coins, two 25 paise coins, or we can give one 50 paise coin. Similarly, for 75 paise coin, we'll have two options, that is giving 25 paise coin 3 times or giving 150 paise coin and 125 paise coin. This is the only way, right? So the number of ways, and in fact we have to find at least 1 rupee, right? So apart from 75, then he will be getting 1 rupee or more than 1 rupee. So these are the ways which is not satisfying this condition. So we can just count them. This is 1, this is 1, this will be 2, and this 2 will be 2. So overall there are 6 cases wherein he is not getting at least 1 rupee coin. So the other cases he will be getting at least 1 rupee coin. So the answer would be 60 minus 6, which comes out to be 54. So 54 becomes the right answer. Now let's take the next question. Question number 2. Here it says that we have to consider a class wherein there are 5 girls and 7 boys, and the number of different teams consisting of 2 girls and 3 boys we have to form, such that 2 specific boys A and B, they refuse to be the member of the same team. So in this case, what we can do is that we can ignore this condition and try to figure out that irrespective of the any constraint, what would be the number of cases. So here out of 5 we can select 2 girls in 5C2 ways. Similarly, out of 7 we can select 3 boys in 7C3 ways, right? This on calculation comes out to be 350. From here, we have also included a case wherein both A and B are part of the group. So we can just ignore that. So in that case, we have to select 2 girls, that will be in the case, that will be 5C2 ways, and assuming that these 2 have already been selected and we have to select 3 boys, then we have to only select 1 boy out of 5 boys. Why 5 boys? Because these 2 are already a part of 7 boys. So that can be done in 5C1 ways. This on calculation would be 50. So we have to just deduct this, and that should be our answer. So 300 is our answer for this question. Now let's take the third question. Here it says that there are n men and 2 women participating in a chess tournament, and each participant plays 2 games with every other participant. Now if the number of games played by the men between themselves exceeds the number of games played between the men and the women by 84, then we need to find the value of it. That's a very simple question. What we can do is that among the men, if they want to play against each other, and every participant, every pair of participants play at least exactly 2 games against each other, then we can say that the different combination of men taken 2 at a time is this, and we have to multiply it with 2 because every time they are playing 2 games, minus men playing against women 2 games each. So m number of men is playing against 2 women. So this is the number of games if they are playing exactly 1 game, but we have to multiply it with 2 because they are playing 2 games each. This, as per the question, is 84. So if we calculate, this will be 2 factorial, which is nothing but 2 itself, into 2 minus 4 times of m is equal to 84. This 2 will get cancelled out, or we'll be getting m square minus 5 of m minus of 84 is equal to 0. This is a quadratic equation which can be easily factorized as this m plus 7. This is equal to 0. Clearly m will be negative in this case, so we'll be considering the value of m to be 12. So the answer for this question is 12. Now let us take the fourth question. It says that all possible numbers are found using these digits. So we have to count the number of digits. This is 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9-digit numbers. So 3, 4, 5, 6, 7, 8, and 9. And the number is such that the odd digit occupy the even place. So this would be the even place, this would be the even place, this would be the even place, and this would be the even place, right? These are the places where odd digit will go. So we have to find all possible such numbers. So what we can do here is that the odd numbers are 1, 1, and 3, right? And the even numbers are 2 has to be used 4 times and 4 will be used 2 times. So there are 3 odd numbers and 6 even numbers. Now what we can do is that in this even places we have to place odd numbers, so we can select any 3 out of these 3 places, right? Out of these 4 places we have to select 3 places wherein we will be putting these odd numbers. That can be done in 4C3 ways. Now once we have selected any any 3 place, then these numbers can be arranged in 3 factorial divided by 2 factorial. Why so? Because 1 is repeating twice. Once this is done, then rest of the places will be occupied by even numbers, and these numbers can be arranged in 6 factorial divided by 2 is used 4 times, so it will be divided by 4 factorial, and 4 is used 2 times, so it will be divided by 2 factorial. So we have to calculate this. On calculation, I'll be getting the answer to be 180. Now let's take the fifth question. Here it said that what is the number of distinct terms in the expansion of this? We all know that if we expand this, then each of the term will contain A, B, C, and they will have some parts or the radical sign, and that will be say P, Q, and R. Each of these term will find that P plus Q plus R will be equal to 20, right? That is this. So this question reduces to finding the number of integral solutions of non-negative integral solution of this equation, which anyway we know the formula is n plus r minus 1 c r minus 1. So the value of n is 20 here, the value of r is 3 here, minus 1 c 3 minus 1, which comes out to be 22 c 2. On calculation we'll be getting it as this. So the answer comes out to be 231. Now let's take the sixth question. Here it says that a committee of 11 members is to be formed, which include 8 male and 5 female, right? Out of these, we have to pick a committee of 11 members. And if M is the number of ways wherein this committee is formed, which has at least 6 male, and N is the number which has a committee with at least 3 female, then we have to find which of the following option is correct. Now, if we just observe closely, then if we take all the 8 males, right, then we need to select at least 3 females always, so that the number becomes 11. Correct? That means at least 3 female will always be there. There cannot be a committee wherein the number of female is less than 3, because the total number of male itself is 8. Similarly, if we take all 5 female in the committee, then we have to select at least 6 male, so that the number 11, the number of member in the committee becomes 11. That means in either of the case, we can say that both the value of n and both the value of m and both the value of n and m will be equal. Or we can say that m is equal to n, which is nothing but selecting any 11 out of these 13 members, 8 plus 5. So this will be 13C11, which effectively is 13C2. On calculation, it will be 13 into 12 divided by 2, or 78. So option 1 becomes the right answer. Now, question number 7 says that there are 20 pillars of the same height and they have been erected along the circular stadium. And if the top of each pillar has been connected by beams with the top of the other two non-adjacent pillars, then what is the total number of beams? So clearly, if I just draw that this is a circle and these are the pillars, this is the top view of that, right? And non-adjacent are connected by another beam, right? Something like this. So clearly here we can see that this is nothing but, if we draw a 20-sided polygon, then the beams are nothing but the diagonals. Correct? So we have to find the number of diagonals. So here it will be 20C2 minus 20 will become the number of diagonals. So let us calculate it. So this is nothing but 20 into 19 by 2 minus 20, or it is 180 minus 190 minus 20, which comes out to be 170, and that becomes the right answer. Now here the question says that a group of students comprises of 5 boys and n girls, and if the total number of ways wherein the team of 3 students can randomly select it such that it contains at least 1 boy and at least 1 girl is this much. So we need to find the value of n. It's a very simple question. Let us assume that we have to make this committee wherein it should have 1 boy and 1 girl. Then there are 2 cases. Either we take 1 boy and 2 girl, or we can take 2 boy and 1 girl. Correct? So considering this, it will be out of these 5, we have to select 1 boy. So it can be done in 5C1 ways. And if I want to select 2 girls, then it will be NC2 ways. Correct? Plus, this case will be 5C2 into NC1. This together is 1750. So let us do the required simplification. So here it will be 5 into n minus n into n minus 1, in fact 5 into n into n minus 1 divided by 2 plus this is 10 into n is equal to 1750. On simplification, we'll be getting n square plus of 3n is equal to 700. Solving this, we'll be getting the value of n to be 25. So 25 is the answer for the question. Let's take the 9th question. Here it says that 5-digit numbers are randomly formed by using the digit 1 and 2 only. How many numbers are divisible by 3? So since we have to make only 5-digit number, what we can do that we can start with all number to be 1. Clearly this is not divisible by 3. Reason being the sum is not multiple of 3. But if we change one of the 1 and replace it with 2, then definitely we can see that the sum is 6 and it is divisible by 3. So the number of numbers so formed will be what? Number of ways wherein we can arrange this. So it will be 5 factorial divided by 4 factorial, which comes out to be 5. Correct? Next, can we replace 2 ones by 2 twos? Again, 1 1 1 2 2. This sum is 7, which is not divisible by 3. So we need sum to be 9, right? For that, the only case is we take 2 4 times and 1 time. Again, this can be arranged in 5 factorial divided by 4 factorial, which is 5 ways. So the total number of ways is 10, and 10 becomes the answer. Now let's take the last question. Here it says that India and Pakistan, they play one-day international cricket series until any one team wins 4 matches. No match ends in a draw. So in how many ways the series can be won? So important thing here is that we don't have to favor India only. Here we need to find how many ways series can be won. So the number of ways, for suppose n is the number of ways wherein India can win a series, the same will be the number of ways wherein Pakistan can win. So let us assume that India has to win the series. Whatever the number comes, we have to just multiply it by 2. So the series keeps on going and no match ends in a draw, and until somebody or until any of these teams win 4 matches, the series will keep on going. So the minimum number of matches required is 4, correct? So that India wins the 4 matches right from the match number 1 to match number 4. This can happen only one way. But if the series ends in 5 matches, then the only way wherein it can happen is that the 5th win would be India's win, and that would be the 5th match would be won by India, and that would be the 4th win of India, right? And in the previous 4 matches, what will happen is that there will be 3 win of India and 1 loss by India, right? This particular thing can happen in various ways. It could be WLWW or LWWW, something like that. That means the arrangement of this thing, which can be done in 4 factorial divided by 3 factorial, that is 4 ways. Similarly, for 6 matches, the 6th match will be a win, and before that there will be 3 win for India and 2 loss by 2 matches will be lost by India. This thing can be arranged in 5 factorial divided by 3 factorial into 2 factorial ways, which comes out to be 10. And if it takes 7 matches, then the 7th match will be the 4th win for India. Before that, there will be 3 win and 3 losses, and this can be arranged in 6 factorial divided by 3 factorial into 3 factorial, which comes out to be 20. So if I add 20 plus 10 plus 4 plus 1, it comes out to be 35. And we have to multiply it with 2, so 70 becomes the right answer. 35 is the number of ways wherein India can win. Obviously, 35 will be the number of ways wherein Pakistan can win. So overall, series can be won in 70 different ways.